forget, on Blackboard, here's the point breakdown for the final. And pay attention to what I'm doing today. It will help you on next Wednesday. We will not have class on Monday. It's finals week. All right, let's get started. I'll do a fresh opening. Good morning, everybody. And let's go back and look at open up a couple of the reviews here. I'll do one at a time. If I remember correctly, we ended up with, oh, my memory still works. Hot dog. I haven't used that expression in a decade. I probably won't ever again. But anyways, we have 1 mole equals the number of things. I did some problems on that. And then for mass calculations, you should know how to, come on in, how to do the following. And let's go to a problem set. All right, let's look at number 4. I'm going through this. This is all on Blackboard. And if you look at this, the question is, how many grams of C3H8, which is propane, are needed to make 24.6 grams of CO2? And this is one of those 3-step problems where you have to, first step, you go from whatever you're given in grams, you convert to moles. And therefore, I'll use, I get to say it one more time, your good buddy, your good friend, unit analysis. And how do you do that? Here are the grams. You want to go to moles. Moles goes on top. Grams goes down there. What do you know? And it'll be on important information for the final. Which you can look at in the lecture folder. And if you look at this, you'll see mass calculation for reactions. Remember, mass means weight, and therefore it says first convert A, whatever you're given in grams, to moles. Then moles of A to moles of B, and the third step, whatever, now you have moles of B, and you want to get grams of B. This is available to you. Let's go through the problem set. And first step, what I'm given in grams, which is the CO2, I convert to moles. Remember, 1 mole equals the molecular weight, and the molecular weight is the sum of all atomic weights, which is given to you in important information. And now we can convert that to moles. The next thing is converting moles of A, in this case CO2, to moles of the answer we're trying to get in weight, which is propane, C3H8. Now, remember, the coefficient, the number in front of the formula of a balanced chemical equation gives you molar ratios. And that means 1 mole of propane plus 5 moles of oxygen make 3 moles of CO2 and 4 moles of water. And we want to go from CO2, which we're given, and we figured out the moles, to the moles of what we're trying to get in grams. And therefore, I start with this. I want to end up with this. How do I do that? Unit analysis. This goes on top. This goes underneath. Where do I get those numbers? 1 mole of propane, C3H8, makes 3 moles of carbon dioxide, CO2. Remember, these are exact numbers. So I start with 3 significant, end up with 3 significant. Now you'll do step 3, and step 3 is where you want to get to the grams of propane. You have moles. We've done this already. How do you know that? Well, you go back to important information. 1 mole of a compound equals the molecular weight of a compound in grams, and the molecular weight is the sum of all atomic weights. And now, if we come over here, we'll go back here, and did I do this right? Checking. All right. I have so many moles of propane. I want to go to grams. I'll use unit analysis. Grams goes on top, moles here. How do I get that number? 1 mole equals the molecular weight, in this case, of propane, which is 3 carbons, 8 hydrogens. You add it up. Move the cursor so you can see it. And remember, when you're doing an addition, you have the same number significant figures past the decimal point as the number that has the fewest significant figures. This has 1, 2, I round this off to 1 past the decimal, I get 41.1, put that in here, this cancels out, and I get my weight, and I get my 10 points. Yes, Daryl?
Where did the 3 come from in step 2?
Can I talk louder?
Where did the 3 come from in step 2?
All right. What's the molecular formula?
Step 2.
3 and step 2.
Step 2. Oh, this one.
Yes.
All right. Hold on, because I can't stretch my arm any further, so I'm going to lower it a little. And as always, all questions are good questions. The question is, where did this come from? From the balanced chemical equation. The coefficients are molar quantities. 1 mole, the number in front when you don't see 1 is 1. So 1 mole of propane makes 3 moles of carbon dioxide. And that's where it came from, because the coefficients are molar quantities. Oh, by the way, and for today, pay attention to good notes, or at least remember which ones I went over. Speaking about that, hold on 1 second, important thing. My lecture for today. All right, let's continue on. And the coefficients are molar ratios. And that's everything for test number 2. I'll say it again, and I'll probably say it more than once this morning. Use your hourly exams as practice problems for the final. Look at the high point problems too. Yeah. All right, let's move on. All right, I didn't correct the mistake, but don't forget, 1 torr, when we talk about gases, first thing you should know is pressure. 1 torr equals 1 millimeter of mercury, and I have that wrong. Let's see, it should be correct on important information. and it is corrected there. And you should know that, and this is given to you, 760 torr equals 760 millimeters of mercury equal 1 atmosphere. And since I should share this morning, let me give you something to try on your own. Now, why don't you try this one? How many atmospheres is 851.6 torr? Get out of Sam's way so you can see it. I'll tell you, keep your feet off the furniture, but you can keep on
My dog sleeps on my couch. So
What?
My dog sleeps on my couch, so she's really cute.
there. She has 3 claws, doesn't she?
For the most part, yeah, she won't.
All right, let's do this. And the question is, how many atmospheres is 851.6 torr? And now, the only number you have to work with is 851.6 torr. What do we want to get to? Atmospheres. And if we can do it in one step with a ratio, I get to say it again, you use your good buddy, your good friend, unit analysis. Whatever you're trying to get to goes on top. Whatever you're trying to get rid of goes on bottom, unit-wise. You know that 1 atmosphere equals 760 torr. These are both exact numbers. Here's what my calculator gives me. Notice this is 4 significant figures, exact numbers. My answer should be 4 significant figures. How do you round that off to 4 significant figures? I'll give you 2.1 seconds. 0.05, 0.06, times up, and that would be 1.121. And that would be your answer. One thing I just remembered I didn't do on Wednesday that I'll do today at the end of when I'm talking is I forgot to show you how to calculate how many points you need on a final to get the grade you want. It's a good thing to know. All right, next thing I talked about was Boyle's law. And Boyle's law is P1 times V1 equals P2 times V2, where P1 is the initial pressure, V1 is the initial volume, P2 is the final pressure, V2 is the final volume. You'll be given this important information. Sorry about Blackboard being slower than a snail this morning. And if you look at problem 6, let's go through it. First of all, if a balloon has a pressure of 658 torr and a volume of 1.894 liters, what is the pressure of the balloon if the volume is increased to 5.133? So what we're going to ask to find is a final pressure, P2. We're given initial pressure and volume and initial final volume. Whenever you see a problem with only pressure and volume, immediately you know it's Boyle's law. And therefore, P1 times V1 equals P2 times V2. What are we solving for? P2. We want to get a balloon on one side. How do you do that? You divide by whatever you're trying to get rid of. Whatever you do on one side, you have to do on the other. I did. Anything divided by itself becomes the number 1. I like rewriting it, but you don't have to. But good habits, Dr. White doesn't break. And now I'll put in, there's P2 equals V1, P1 times V1 divided by V2. When you set it up like this, it's easy to put the numbers in. You don't have to go back and read the problem, and that makes your life easier. And notice I'm in my 3, 4, 4. Therefore, when you do a multiplication division, whatever number has the lowest significant figures should be the same number of significant figures your answer should have. And therefore, that's 3. And that's how you do it. Let's move on. The next thing is the ideal gas law. And the ideal gas law is PV equal nRT. And the ideal gas law tells you when to check your tires. When the temperature goes down, the volume of your tires will, or pressure will go down, because volume and moles and R should stay constant unless you get flat. I hope you don't. And same thing in the summer. Did I ask a question like that? I did on test number 3. And the temperature goes up, your pressure goes up. Now, how do you know when to use PV equal nRT when you're talking about a gas and none of the variables change? And let's look at an example. Let's look at number 10. Oh, by the way, you won't believe some of the fun things I put on the final. Yes, I had fun. We'll get a chuckle out of it, baby. But let's look at the following problem. If you burp 86.75 grams of CO2, most of your burp is carbon dioxide, at 545 millimeters of mercury and at 34.6 degrees C, then what is the volume of your burp? So what are you being asked to find? A volume of a gas. Is anything changing? No. Immediately, that quick, actually quicker I hope, you know this is PV equal nRT. Let's go back to important information. If you notice, this will be given to you. Pressure for PV equal nRT has to be in atmospheres. It never will. I have yet to see in my life, and I don't expect ever to see in my life, a gauge that measures atmospheres. It does things like torr, millimeters of mercury, and others which we don't do in this class. Volume will be in liters. I'll always give it to you in liters. If I'm going to give you volume, you don't have to convert. And it's the number of moles, and I've yet to see a balance that measures moles. It measures grams. and you know how to go from grams to moles. And temperature, I have never in my life seen temperature measure Kelvin. For this class, Celsius, centigrade, whichever one you like, I like the old one once in a while, degrees C, you'll always be given, you have to convert. And the universal gas law constant is a constant, and I'll give it to you. When I took chemistry, you had to memorize all these. Until about a year ago, when I taught this class last spring, in the past, I would ask students to memorize everything, except I would give them R, which is a little gift, but now you don't have to, this is given to you. All right, let's go back to the problem. We're trying to find volume, PV equal nRT. We want volume alone on one side. How do we get rid of P? Divide by it. Whatever you do to one side, you do to the other. And when you do that, you get volume equals nRT over P. But now the word comes, and now you have to convert things. And first of all, pressure has to be in atmospheres. We have millimeters of mercury, we want to go to atmospheres. Atmospheres goes up here, millimeters of mercury go there. Where do you get that number? 1 atmosphere equals 760 millimeters of mercury. And if you go right here, it's given to you. See how nice I am? Everybody can say yes, not really, no. And next, temperature. Temperature needs to be in Kelvin. It's in degrees C. What is the conversion? Well, let's look over important information, and this will be given to you right up there. K Kelvin equals degrees C plus 273. 273 is an exact number. And here's the temperature in degrees C plus 273. We get that in Kelvin. Finally, N is moles. You're given the grams of CO2. You want to go to moles of CO2. In case you forgot, let's go back here. 1 mole of a compound equals the molecular weight of that compound in grams. And then the molecular weight is the sum of all atomic weights. And here, we'll go back to the problem, and you'll see that we're trying to find, let me get the problem back up so you can see it. We're dealing with carbon dioxide, CO2. Therefore, we have grams. We want to go to moles. We'll use unit analysis. Moles of CO2, grams of CO2. Where do you get that number? By the molecular weight. That's the sum of all atomic weights. 1 carbon, 2 oxygens, 44.0. You get 1.97. You put everything in here, and moles are universal gas law, temperature, atmosphere, and you'll get 69.4 liters, which I don't think your lungs can carry that much volume. Because how many of you are familiar with a 2-liter bottle? That's about 35 of them. No, I don't think I could work that much. But it was fun to do. All right, we have Dalton's law of partial pressures. The sum of the partial pressures of a gas equals the total of a mixture of gases, and the partial pressure, P1 or P2, is the pressure of the gas in a mixture if it were alone. All right, next thing, I talked to you about boiling liquids. Remember, when you boil something, the vapor pressure from the liquid you're heating has to equal the atmospheric pressure. And at that point, that's the boiling point. And the higher up you go in the atmosphere, the lower the atmospheric pressure. Therefore, that lowers the boiling point because you need less energy to get to the same vapor pressure. So if you look at test number 3, I asked, I don't know if I used Denver or Himalayans. I think I used Himalayans. You go to Kathmandu, which I probably never will go to, how many of you know where Kathmandu is? It's a, you don't know the song, people. Oh, coming this weekend, I'll be posting on Blackboard Dr. White's favorites, and I'll have my favorite groups, songs, and movies, and a couple of books that you people, I don't think know about, you should. So feel free to download that. All right, Kathmandu is up in the Himalayas. It's the city you go to and stop off at first before you start climbing the Himalayas. And there's a famous song too about that, but I'll let you figure that out on YouTube. And when you go up at Kathmandu, very high altitude, what happens to the boiling point and why? And the boiling point decreases because the atmospheric pressure decreases. Let's move on to solutions. And solutions are mixtures of different chemicals that neither chemical or in the mixture, any chemical reacts, and it's homogeneous, the same throughout. And you should know, solvent, component of the mixture that's present in the greatest amount. Solute, all the other components. Colloidal dispersion, that's where you don't have a true mixture, but you have small particles of one compound or substance dispersed in another substance. How can you tell? Shine a light through it and the particles scatter light, unlike a solution which will let the light through. Did I ask a question like that? I did on test number 3. Next, I talked about like dissolves like. Things that are polar are soluble in polar things, or I guess type works too. But anyways, things that are polar are soluble in polar things. Things that are nonpolar are soluble in nonpolar things. Water is polar, vegetable oil is nonpolar. And I asked a question like that in test number 3, which is why I put down notice. That's something that'll help you the rest of your life. Next, we have solubility of a solute. That's the maximum amount of solute that can be dissolved in a given solvent. So when I'm at the maximum amount, I can't dissolve anymore. It would precipitate out. Saturated, you're at a very high level of solute present, but you can still get a little bit more. Dilute, you have a very small amount of solute present compared to the amount of solution present. Concentrated, you have a lot. And finally, aqueous means the solvent is water. And aqueous is abbreviated by AQ, and usually that's smaller A or not a capital. AQ, and that tells you the solvent is water, which I asked on test number 3. Speaking about water, I'll be right back. I have to, this review stuff is thirsty stuff. Anybody leave their gray hat and scarf out there? Next, I talked about molarity, and molarity, which is shown by capital M, is defined as moles of solute, and for this class, 1,000 milliliters of solution. And on labels of things, you'll see something like this. And the question is, what does that mean, and what's the solvent of that solution? Let's talk about this Capital M tells you molarity. And therefore, what this really means is 4.57 moles of HCl, hydrochloric acid, per 1,000 milliliters. What's the solvent? Aqueous tells you the solvent is water. Now, where this helps is when we talk about molarity, there's a certain two-step molarity problem, which I'm going to go through right now. Okay, now, there we go. And let's look at, let's do number 12, where I made a mistake. It was corrected. Remember the first day of class I told you I don't walk on water unless it's frozen, and even then I stay off it? See, I wasn't lying to you then. All right, let's go through it. How many grams of H2SO4 are needed to make 345 milliliters of a 6.77 times 10 to the minus 2 capital M H2SO4 solution? H2SO4 is sulfuric acid. So the question is, what do we do? Well, first of all, what are we trying to find? This, grams of sulfuric acid. What do we give it? Milliliters? And this number. As soon as you see capital M, you know that's molarity. And molarity is moles per 1,000 milliliters. And that was my error, which I corrected, thanks to one of you who found it. And now, when we're trying to deal with molarity and find grams, immediately you know it's two steps. And as I showed you on important information in the final, you'll see two steps. First one, you go from milliliters to moles. Second step, you go to the answer from moles to grams. Let's do that. And therefore, we have so many milliliters of the solution we want to make. We want to get the moles of H2SO4. Once again, you use unit analysis. Whatever I'm trying to get to goes on top. Whatever I'm trying to get rid of, milliliters, goes underneath. Where do I get those numbers? From the molarity, because you knew this really means that. I put that in, I get the correct number this time, hopefully. And next, I now want to get to grams. I have moles of sulfuric acid. Second step, moles to grams. Here's the moles. We want to get to grams. We use unit analysis. Grams goes on top. What we're trying to get rid of goes underneath. And where do we get those numbers? From 1 mole equals the molecular weight of a compound. And just to show you, it's right here, important information. And now, let's go back here. Where do we get this? 1 mole equals the molecular weight. When I have help, the molecular weight is 2 hydrogens, 1 sulfur, 4 oxygens. You add it up correctly. And Dr. White originally, and you get that number, put it in there, do the math, and that's the number you get. And this is how you do molarity. And use molarity to figure out how to make a solution by how many grams. You should know how to do this. this wipe out? I think I did. I covered everything in there. Check this out one. All right, you just took it, but let's go over it again quickly. Test number 4 material, and that is acids and bases. And you should know that a Bronsted laurate acid is a proton donor. A Bronsted laurate base is a proton acceptor. And here are acids, here are bases you should be aware of. One base I don't have up there is sodium bicarbonate, NaHCO3. And while you're writing that down, I'll be patient. Well, tonight at midnight, I'll be giving a speed note-taking lessons. That joke doesn't work anymore. So I won't use it again the rest of the semester. An important thing, water reacts with itself, and because of that, you have Kw, the ionization constant for water, named after Dr. White, I wish, and that is hydronium ion times hydroxide ion concentration equals 1.0 times 10 to the, have this 1, but 1.0 times 10 to the minus 14. And there are different solutions, acidic, basic, and neutral, and I'll cover this again in a little while. Important thing, pH. One of the most important things I've taught you this semester, and you'll probably use elsewhere, is pH. pH is equal to minus log of the hydronium ion concentration. Remember, if, for my gift to you, the hydronium ion concentration equals 1.0 times 10 to the minus x, then the pH is X. And this scale you should know, pH. When the pH is 7, you're at neutral solution. When the pH is below 7, you're acidic, which is why your stomach has a pH of less than 7, like about 2 or 3, because there's acid present in there. One of the miracles of life I always think about is the fact that I and all of you have cells that make hydrochloric acid. Organic stuff it makes too, but that, since I'm an organic making something inorganic, this is amazing to me. When the pH is above 7, you have a basic solution. Therefore, if you have a neutral solution, you add an acid, the pH will drop. If you have a neutral solution, you add a base, the pH will increase. If you have a buffer solution and you add a small amount of acid or base, the pH will stay the same, which I had on test 4. And there's buffers. And for titrations, you should know when the pH is neutral, when one thing neutralizes another, acid and base, moles of acid equals moles of base, and therefore you have milliliters of acid times molarity of acid equals milliliters of base times molarity of base. And if we go back to the problem sets, if you look at problem 4, question is, if a solution has a hydronium ion concentration of 1.0 times 10 to the minus 3, what's the pH? We're trying to find pH. We're given the hydronium ion concentration. You're given pH equal minus the log of the hydronium. Put that in. X is 3. When it's 1.0 times 10 to the minus x, and therefore it's 3 and it's acidic. Now, if I'm mean and I give you the hydroxide, you've got to do 2 steps. First, you have to calculate the hydronium. How do you do that? Use this equation, which you're given, and you solve for hydronium, divide both sides by hydroxide. You get this. You put this in, put the numbers in. This is the hydronium. And you're trying to get pH. Therefore, second step, calculate the pH. pH is minus log of H3O plus. Put that in. X is 11. It's 11. That's basic. For titration, if you have to add 1.35 times 10 to the third milliliters of 1.35 molar NaOH solution to neutralize 1.87 times 10 squared of an aqueous HCl solution, what is the molarity of the solution? And the answer is, find out. And first of all, we're trying to find molarity of HCl. When you see the word neutralize, that means it's a titration. And neutralization for titration, this is given to you, an important information. Moles of base, moles of acid, which is given to you milliliters of base times molarity of base equal milliliters of acid times molarity. Put the numbers in. What do we want to solve for? This. Therefore, we divide both sides by the milliliters of HCl. This cancels. I rewrite it, put the numbers in, and that's the molarity. You should know this. Next, I talked about organic chemistry. Unfortunately, not enough time spent on it, because this is my true love in life, one of them. And remember, how many bonds to carbon? 4. How do you know how to fill in? Once you fill in the hydrogens for this molecule, you know there are 4 bonds to carbon. Why don't you go ahead and do that? While you do that, I'm going to get a refill. All right, you know there are 4 bonds to carbon. This carbon has 1, 4 minus 1, 3, same thing here, same thing here. This carbon, how many bonds does it have? Count lines. 1, 2, 3, 4, 4 minus 4, 0, don't have to do anything. This has 2 bonds, 4 minus 2, 2 hydrogens, this has 1, 4 minus 1, 3, and that's how you do it. Next thing I taught you were a couple of general reactions and how to apply them. One definition I gave you, which is important in today's world, is pollution. Hydrocarbons, molecules with only carbon and hydrogen atoms. And there are 2 types, saturated, unsaturated. My gift this morning, I won't ask you these definitions, these 2. Others I can, but not these 2. Functional groups, how to find one, circle, look for anything that's not carbon or hydrogen, or not a carbon-carbon single bond, that's where the fun is. I showed you how to draw them and count carbons. One of the reactions I asked you to learn was saturated hydrocarbon. Here's the general reaction. Why don't you do this reaction on your own? What would be the product or products for the following reaction? Need more time. All right, what is this? It's a saturated hydrocarbon. It gives carbon dioxide and water plus heat, but I'm interested in the molecules. This is a saturated hydrocarbon, therefore the answer here is carbon dioxide plus water. Next one I taught you was hydrogenation, which is used to make your hydrogenate things like fats and oils. And general reaction, whenever you have a double bond reacted with hydrogen, a catalyst, platinum, palladium, or nickel, you break one of the bonds, the double bond, and add 2 hydrogens to each carbon of the double bond. Why don't you try this molecule? Reacted with hydrogen, and I put down catalyst, I should put down nickel, and therefore what would be the product or products for that reaction? Organic. All right, anybody need more time? Anybody don't want to say they need more time, need more time? Alright, what do we have here? Double bond. Reacted with hydrogen and a catalyst. The catalyst can be nickel, platinum, or palladium. And what happens, you break one of the bonds, it's called a pi bond, but I'll never ask that on the test. Do you break carbon-to-carbon single bonds? No. So I have 1, 2, 3, 4, 5 across. What's this called, methyl group? So I have 1, 2, 3, 4, 5 across my methyl. Here are 2 carbons, double bond. These 2 break one of the bonds. Each one gets a hydrogen. And now I know there's 4 bonds to carbon, so I can put this in. And that's your answer. And that's something you should know how to do. I'm not going to ask you about fats and oils and triglyceride watch online. But you should know how soap works. One of the things I would like you to leave my class this semester knowing how soap works. Have you washed your hands this morning, which I hope we all did, I did. How does soap work? You should know. Soap has a non-polar tail, polar head. Water is polar. Dirt is non-polar. The most important part of the puzzle is like dissolves like. That means things that are polar are soluble in polar things, things that are non-polar are soluble in non-polar things. If we look at a piece of dirt, highly magnified, you know, one right here, and it is highly magnified. The soap looks at dirt, water will look at dirt and says, you're non-polar, I know life dissolves life, I want nothing to do with you. But the soap molecules say, oh, my tail is non-polar, you're non-polar, so I'll attract like this. And that's called a micelle. And a micelle now looks to water, polar, and water says to the micelle, I'm polar, you look polar, let's go down the drain together. And lo and behold, they did. Notice my hands are now clean. And you should know how soap works. Everybody got this down? Who wanted to get it down? That was my job. Putting together a machine gun over here. I gotta turn my back on them. Definite question.
So just to clarify, we won't need to know weak fat, thick fat, unsaturated, saturated definition?
You're right.
Not being fat, or being fat.
Well, you can know it for the rest of your life, but I'm not going to put it on the front. I may. I'm going to rewrite the final. I have time. Thanks to your colleague over here, I'll pop those questions. No, I'm not. Sorry. All right. If you look at the syllabus, each test, you're going to have 3 tests and your final. And each test, the final is worth 100 points, and each test is worth 100 points. Now, the question is, how many points do you need on the final to get a good grade? And what I'm going to do is show you a method. I'm going to ignore the lab, because most of you hand in your labs, and the lab average in here for everybody who hands in all their labs, which most of you everybody here has, is about 90–91%. So if you're getting an A, that's not going to help you. If you're getting below that, your lab total will bring you up a little bit. So you can ignore it for what I'm going to do now. Take the sum of your 3 highest tests, and if you did an extra credit, add that along, you'll get a number called X. If you look at this, if you're shooting for an A, 360 minus X, which is 90% of 400 points, is the amount of points you need to get an A on the final. Which if you had 3 tests and you got 300 points, no extra credit, 100 points on each one, you'd only need 60 out of 110, which is not bad. Same thing for B, 320 minus X, C this, D that. Now, with that said, let me have everybody's attention. I'm going to warn you something. I do this, but a number of you are in very good shape. And you'll say, oh, I only need a few points on the final. I don't have to study hard. And I've seen this too many times in this class and others. Students are in that position, don't study hard for the final like they need at every point, and then guess what happens? They don't do good on the final, and they drop a whole letter grade or sometimes 2 letter grades because they totally bombed the final. Do people know what bomb the final means? I wasn't sure if I was using a generation gap phrase. So even though you'll see that for a grade you want, you're in good shape, I would highly recommend each and every one of you study like you need every point. Now, there's 2 things I need to do.